this video, I want to talk about maximizing profit using the profit function. In a different video, we'll have one using the marginal method. So this is the profit method for maximizing profit. So we typically start with a demand function, and let's just suppose that's our demand function, and our cost function, not marginal cost, just cost, is suppose that. And remember, we have to always ask ourselves if demand is inverted. Since this is Q as a function of P, it is not inverted. So to invert it, we must solve this for P. So we're going to move the 0.5 P to one side. The 125 stays. And then the Q moves to the other, so minus Q. Divide everything by 0.5, which is the same as multiplying by 2, and that should not be Q, that should be P, is therefore 250 minus 2Q. That is an inverted demand function. Cost function is already given, so we can use the P function to get revenue. Revenue is P times Q. And don't make it too complicated. Q is just Q. So we're going to multiply everything in that P function by Q. And therefore we get 250Q minus 2Q squared. Greek letter pi is profit. So we can take revenue, which is 250Q as we just did, minus 2Q squared, minus cost. A mistake students sometimes make is they do not subtract all the pieces of cost. So don't do plus 2Q, do minus 2Q. Combine terms, and we will get 248Q minus 2Q squared minus 50. Take the derivative, which is 248. 2 times 2 is 4. Drop the power on the Q by 1. Whoops. There we go. That's okay. So far, so good. That equals 0. I thought I had made a mistake there. Solve this for Q. So 4Q equals 248. So Q is therefore 62. So if you are interested in maximizing profit, you would sell 62 units. To get the price, we take that 62, oops, I went too far, and we would put that back into the P function. P is 250 minus 2 times 62. 2 times 62 is 124. Do that subtraction, you would charge therefore $126. Bottom line, if you're interested in maximizing profit, you would sell 62 units at $126 a piece.